Hi, everybody. We're going to take up the answers. We're going to take up the questions from yesterday's homework, and that was 8.2. So on your Edwins, it was this one. Oh, 8.2, using variables to write pattern rules. So you had to complete number 4, 5, 6, 8, and 9. So let's take a look at those. I got a lot of good feedback on using the chart paper method to do the lesson, so I think I'm going to go ahead and just stick with that. So question number 4, use words to describe the pattern rule for the total number of blocks in each figure below, then use an algebraic expression to describe the pattern rule. Okay, so we have here the pattern, 1 red square, 4 green triangles, 2 red squares, 4 green triangles, and 3 red squares, 4 green triangles. Okay, so our pattern rule. The number of red squares increases by 1. So the number of red squares is increasing. It's going up. 1, 2, 3. We can see that. But the number of green triangles stays at 3. Oh, that should read 4. This is why it's a good idea to proofread before you start recording. But that's the world we live in. So because the number of red squares is the one that's changing every time, 1, 2, 3, that's the variable. Variable is the thing that changes. The green squares, it's always 4, so that's the constant. Constants never change. Then so we describe what was happening in the pattern. Now we need to find an algebraic expression. We need to find an expression that helps us find the total number of blocks. So first thing I did was I created a T-chart to record, well, how many blocks are there? In the first figure, there's 5 blocks. Notice I'm not focusing on color when I do this. I'm just trying to figure out how many blocks there are. In the second figure, there's 6 blocks. And in the third figure, there's 7 blocks. So I ask myself, well, how do I get from 1 to 5? How do I get from 2 to 6? How do I get from 3 to 4? Going across the chart. Well, 1 to 5, that would be plus 4. 2 to 6, plus 4. 3 to 7, plus 4. And notice 4 is also the number of green triangles that stays the same. The constant is 4, and that just happens to be what we're adding. So that means our algebraic expression is f plus 4. F for the figure number plus 4, and that's all we did. We took the figure number, we added 4, and it gave us the number of blocks. F plus 4. Remember, the variable can be any letter you want. I pick F for figure number. If you want to pick B for block, if you want to pick R for red, it really doesn't matter what letter you pick for the variable. You just got to pick something. Okay? Let's go on to number 2. Oh, sorry, to number 5. Number 5 reads, what pattern stays the same and what changes? Describe the pattern in words. Write an algebraic expression to describe the pattern. Okay, so we have here the pattern for number 5. In the first design, we have 1 yellow square, 2 blue. In the second design, we have 1 yellow square, 4 blue. And in the third design, we have 1 yellow square and 6 blues. All right, so what changes? Well, the number of blue blocks. That's easy to see. It goes from 2 to 4 to 6. What stays the same? The number of yellow blocks. 1, 1, 1. So that means the blue blocks, that's the variable. That's what's changing. The number of the number of yellow blocks is the constant because it's always 1. In this case, it's always 1. 1, 1, 1. Now, I need to figure out my pattern rule. So my pattern rule, the number of blue blocks starts at 2 and increases by 2 each time. 2, 4, 6. But the yellow block stays at 1. Now, what's my algebraic expression? First thing I do is I create a T-chart so I can visually see what it's going up by. Figure number 1 has 3 blocks. Figure number 2 has 5 blocks. Figure number 3 has 7 blocks. So going across, I can see, well, I could do 1 plus 2 equals 3, but remember, the number that it goes across, the pattern has to be the same every time. So yes, 1 plus 2 does equal 3, but 2 plus 2 does not equal 5, it equals 4. So the answer is not just plus 2. I'm a little stuck here. In order to help me figure out what to do, I'm going to look at the column of the number of blocks, and I'm going to try to figure out, well, how much is it going up by? The number of total blocks, how much is that increasing? So 3 to 5, that would be plus 2, and 5 to 7 would also be plus 2. And if you'll remember, the number that it increases by here tells us that we have to use multiplication over here. So we're not going to be adding right away, we're actually going to be multiplying. The figure number times something. And the something we're going to use is the times 2. Times 2, times 2, times 2. All right? Why is it times 2? Because each time it's adding another 2 blocks. 2 blocks, 2 blocks, 2 blocks. So now I just need to figure out, well, how do I get from the product of these two numbers to get to 3? Well, 1 times 2 is 2, but I need to get to 3, so I need to add 1 more. 2 times 2 is 4, but I need to get to 5, so I got to add 1 more. 3 times 2 is 6, but I got to get to 7, so I got to add 1 more. Why are we adding 1 more? Because each time there's still that yellow block, that one yellow block, which makes our algebraic expression f for the figure number times 2 plus 1. F for the figure number times 2 more blocks each time, plus that 1 yellow block. So f times 2 plus 1. Again, I chose f because we're looking at the figure number. You can choose whatever letter you want. Usually in your textbook, it'll go with N. You'll see a lot of Q's and B's. The only ones I really wouldn't do are O, because they kind of look like a 0. X, because you might think it means multiplication. L, you might think is a 1. And even S's, some of your S's, even I know my S's, they kind of look like 5s, so I stay away from those. Y is a really good one. Ones that you're not going to mix up for numbers, basically. All right, let's keep going. And I have been logged out of Edwin. All right, that is great. Let's try this again. Yeah, logged out of Edwin. Okay. Let's go. Number 6. Copy and complete the table of values for this triangle pattern. Okay. Describe how the number of triangles is related to the figure number, and then write an algebraic expression for the number of triangles. Use a variable to represent the figure number. Got it. All right. So, we have here the design that's in the textbook. In the first figure, we have 4 triangles. In the second figure, we have 5 triangles. 1, 2, 3, 4, 5. In the third figure, we have 6 triangles. 1, 2, 3, 4, 5, 6. Which tells me, off the top of my head, that the number of triangles is going up by 1. 4, 5, 6. So that means for the next 2 figures, figure 4 and figure 5, it would be 7 and 8. 7 triangles and 8 triangles. All right, so I completed the chart. So what is the pattern rule? Well, to me it looks, or what's the connection between the number of green triangles and the figure number? Well, from what I can see in the chart, the number of green triangles is always 3 more than the figure number. So if the figure number is 3, the number of triangles is going to be 3 more, 6. If the figure number is 5, the number of triangles is going to be 3 more, it's going to be 8. So that tells me my algebraic expression is just the figure number plus 3. Why plus 3? Because the number of green triangles is always 3 more. More means addition. So figure number plus 3 gives us the number of triangles. All right? Let's look at number 8. Let's see what we got here. The 2 sets of diagrams below represent the same pattern rule in 2 different ways. There's Kyle's pattern and there's Megan's pattern. What stays the same and what changes in each representation of the rule? Write an expression for Kyle's pattern and an algebraic expression for Megan. Okay, so what I did is I created a chart and I started with Kyle. So in Kyle's, there's Kyle's pattern. What stays the same? Well, the number of green squares stays the same. 2, 2, 2. It's always 2. What's changing? The number of red squares. You got 4, and you got 6, and then you got 8. All right? What about Megan's? Well, here's Megan's design. What stays the same? The number of red squares. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. What changes each time is the number of blue squares. I got 2, then I got 4, and then I got 6. Easy enough. Then I need to figure out my algebraic expression for Kyle's design. So I looked at Kyle's and I made myself a little T-chart. I would strongly suggest for those of you having a hard time with coming up with the algebraic expression, draw a T-chart first and just write down the pattern. Because if you can see the numbers, it will help you figure out a lot easier what the algebraic expression is. So figure 1 has 6 squares, figure 2 has 8 squares, and figure 3 has 10 squares. All right? So first I check going across the chart. 1 to 6, 2 to 8, 3 to 10. Well, from 1 to 6, I could go plus 5. 1 plus 5 is 6. Now I need to make sure that works for the next row. 2 plus 5 is 7, but I have an 8 here. So it's not just plus 5. All right? Now, if I'm stuck, I can't seem to figure out what the common difference is this way. Let me look down. Let me check the number of blocks. 6, 8, 10. So then I ask myself, okay, well, is that going up by the same amount every time? Plus 2, 6 plus 2 is 8, 8 plus 2 is 10. And the number that we use as the addition over here, we use under the figure number for multiplication. So times 2, times 2, times 2. Why times 2? Because the number of the number, it's of those 2 green squares there. 2, 2, 2. So now I ask myself, okay, 1 times 2 is 2, but I need to get to 6. So how much more do I need to add to 2? Well, I need to add 4. 1 times 2 is 2, plus 4 is 6. Over here, 2 times 2. Well, 2 times 2 is 4, but I need to get to 8. So how much more do I need to add? I need to add 4. 3 times 2 is 6, but I got to get to 10. How much more do I add? I add 4, which means my algebraic expression is f for figure number, times 2, plus 4. And now that I have this, I could find out for any figure number. If I need to find out for the 17th figure number, all I would do is take out the f, put in the 17, and then just solve. All right? Let's look at Megan's. Now, Megan, if you'll notice, is the exact same. The first figure has 6 blocks, the second figure has 8 blocks, and the third figure has 10 blocks. Now, I know there's no common difference going across the chart yet, so let me look at the number of blocks. Well, 6 plus 2 is 8, and 8 plus 2 is 10. The number that I use here for the addition is going to be my helper when I need to multiply. So 1 times 2 is 2, but I got to get to 6. So how much more do I need to add? 1 times 2 is 2. I add 4. That gets me to 6. 2 times 2 is 4, but I got to get to 8. So I have to add another 4. 3 times 2 is 6, but I got to get to 10. So I got to add another 4, which means our algebraic expression is f times 2 plus 4. Why times 2 plus 4? Because times 2 is the number of blue blocks is going up by 2s, 2, 4, 6. So it's multiples of 2, hence the multiply by 2. And then the plus 4 is for the number of red blocks. So even though, let me see if I can sit up for this. Oh, even though that Kyle and Megan did their designs differently, they still have the same algebraic expressions. Okay, and that is that's last night's homework. So if you have any questions, please put it in the comment section, and I will do my best to reach out to you. Remember that there is a key assessment today, and I can tell you right now, it is one of these 5 questions. So one of these that I just gave you the answer to is the key assessment for today. So please make sure that you're familiar with this, even if you have to watch the video a couple of times. Take care, everybody. Bye-bye.